Hello everyone, welcome to In 5 Minutes. In this video we are going to see the rectangular window, that is the magnitude and the amplitude response of rectangular window. So let us have a look on it. The amplitude response of rectangular window is given by this graph where it is represented as spectrum of WR e raised to j omega. Now we can see that WR e raised to j omega has two important features, that is the width of the main lobe and the side lobe and amplitude. This is the main lobe and these are the side lobes. Now the main lobe width is defined as the distance between the 2 points closest to omega is equal to 0, that is this point where WR e raised to j omega in decibels is 0. So for the rectangular window, the main lobe width, we can see that the magnitude response of rectangular window should be equal to 4 pi divided by capital N. The maximum side lobe magnitude for WR e raised to j omega occurs for the first side lobe and is equal to approximately minus 13 decibels. Now practically, when the magnitude response and log magnitude response of the low pass filter is designed using rectangular window, there are many changes. The filter response differs from the ideal response in several ways. We can see that this is the magnitude response of FIR filter, that is the low pass filter using rectangular window. The sharp transition in the ideal response at omega is equal to omega c has been converted into the gradual transition we can see in this graph. So in the pass band, a series of overshoots and undershoots occur. In the stop band, the ideal response is 0, but the FIR filter has non-zero response. This type of response is called as leakage response. Now, the main lobe of WR e raised to j omega causes smearing of desired transfer function. That is the actual reason why this actual frequency response or the magnitude response of FIR filter is changed. Now, as it is dependent on main lobe width, that is of WR e raised to j omega, and main lobe width is given by 4 pi by capital N, that is the size of the transition region can be reduced to any desired size by increasing this value, that is capital N. But increasing the value of capital N will also increase the number of computations necessary to implement FIR filter. Now taking another case, the side lobes of WR e raised to j omega extend over a wide frequency range, and large magnitude components in HD of e raised to j omega become smeared over a wide range of frequency in H of e raised to j omega. Now again, we can see that the side lobe effects appear both as overshoots and undershoots to the desired response, and similarly in actual magnitude response, these effects appear as non-zero response, that is in stop band. These side lobe effects do not diminish significantly but remain constant as the duration of rectangular window is increased. So we can say that whatever be the value of HD of n included in H of n, the magnitudes of overshoot and leakage will not change significantly, and this is valid only when rectangular window is used. So this result is actually called as Gibbs phenomenon. Now one way to reduce this side lobe effects, we can consider different window sequences having spectrum exhibiting smaller side lobes. We decide smaller side lobes because the side lobes of window spectrum W of e raised to j omega results to the contribution of high frequency components in the window sequence. Now in the case of rectangular window, these high frequency components are due to sharp transitions from 0 to 1 at the edges of the window sequence. Hence, the amplitudes of these high frequency components can be reduced by replacing these sharp transitions by more gradual one or the smooth ones. Now actually, this is the reasons why we developed triangular window, cosine window and many types of other window. We are going to see them in further videos. Thank you.